First of all, let's examine what design editor applications are. The design editor is a software interface that associates application software with view types. It's not a tool, but basically it's a utility that underneath the environment connects the different view types we have for cell views with applications. So if you think about it, and you probably don't too often, but when you open up a layout view, why do you get the layout environment? And when you open up the schematic view, why do you get the schematic environment? Well, the reason is because they're linked together through the design editor. Now, what happens is all design editor applications register certain of their skill functions with the design editor. And then these application skill functions are known as design editor trigger functions. Okay, so what we're going to do is learn how to create our own trigger functions. And the way these are activated is the design editor calls these registered skill functions to configure the design windows whenever the user, for example, opens a cell view, descends the hierarchy into another cell view, or ascends the design hierarchy back up into a cell view. Because in any of these cases, you could potentially change applications, and therefore, based on that cell view, you would trigger a new environment. And we'll learn about how to do that here in the next several slides, as far as having our own customizations come into the environment. Now, if you take a look at the notes slide too, there's a couple of functions that may be useful to you. For example, if you want to get a list of all the view types that are available, that would be potential views that you could create triggers for, you can use the de get all view types function. And if you have a particular view type, you can say de get app info, pass in that view type, and you can determine what sort of triggers are already set up for that particular view type. Again, that's in the notes area. Okay, so we'll declare it and we'll look at that in more depth, but then the next thing we have to do is register it. And we'll use the function dereg user triggers. We'll tell it the application we're registering it for. That means whenever that application gets loaded into memory, our function will run. We aren't going to talk about user application triggers here, but we are going to talk about the user menu trigger, TR user menu trigger. We'll discuss how to define that procedure, which will add a new menu or menus, and the TR user post install trigger, which will modify a menu or menus. Next, we'll look at developing, debugging, and redefining a user trigger function. Now, when you develop a user trigger function, you pretty much are going to do it the same way you did any other skill function, but it's important to know that the design editor will trap any skill errors, so you might not see them pop up like you would a normal message. And what you're going to want to do is set up the debugger so that you can see the stack trace whenever you see an error, because it'll show you what happened up to that point. So in order to debug a user trigger function, you're going to declare it and register it. And then to test it, you won't just run it, because again, it has to trigger. That trigger has to actually happen, so you'll have to open an application window of that type that you've registered the trigger for. Second of all, you have to determine if there are any errors or warnings, so check that CIW. If there were, you're going to have to analyze those and correct those. And then determine if there were no errors or warnings, if the window pops up, did the menu banner appear as you wanted it to? Was the right menu placed in there? Did it have the right text? Does it have the right callback? So again, make sure that the window has been loaded appropriately. Say you do have an error and you want to fix the code. To redefine the user post install trigger function, first of all, you're going to edit the source. Then you're going to redefine the trigger function, basically load it again. Now, you don't have to register it again. Once it's registered, as long as you don't change the function name, that's fine. And then to test it, of course, you'll go back, open an application window of the correct type, and then check if your customization worked as you intended. Now, what you will put in your CDS init file is as follows. So it's tested, it works. Now you want to make sure that every time you start your environment that your customization will happen to the environment that you wanted it to. So first of all, you'll put in the CDS init your definition of your post-install trigger as listed here, and then you'll register it for the particular view type that you want it to affect. So that's what you would then add to your .cds init file. In this submodule, we'll look at 3 user post-install trigger examples. So next we want to look at 3 different examples of user post-install triggers. The first is a option where we're going to add a menu item to the edit menu in the schematic editor window. So we'll add a single menu item. The next one will add a pull-down menu to a schematic editor menu. And then finally we'll reorder the Virtuoso layout editor pull-down menus. Okay, so the different triggers are listed there. For the first one we'll use a post install, then a user menu, and then another user post install. So we'll see the code for that here in the next few slides. So here we want to look at adding a menu item to the schematic edit menu. So what you'll put in your .cds init file is the definition of the TR user post install trigger, and then you'll register it for the schematic window. So what you'll put in your TR user post install trigger function is the following. First, you'll build a menu item if it's not already built, and if it is already built, we want to prevent any warnings from coming up, so we'll check that it's not already there. And then we'll add the menu item to the edit menu, again if it's not already in the edit menu, to prevent any warnings. And the function we'll be using is hi add menu item. We'll give it the name of the menu and then our new menu item that we want to add. Now to note here, the schematic edit menu is a global variable that contains the data structure. And the question might be, well, how do I know what that schematic edit menu global variable is? And on the next slide we'll explain that in more detail and how you can locate that. So in order to find the edit menu data structure to pass into our procedure, we can do the following. We can open up the schematic editor design window, make it current, and then call the function here called hi get banner menus, and then pass in the current window with hi get current window, and you'll see the list it returns back is the list of the global variables for those particular menu structures. And then what you would do is you would count over. You would look at the menu as it appears up on the screen, and you would count over 1, 2, 3, 4, and you would see the word edit, and then you would look in this list and count over 4, 1, 2, 3, 4, and the schematic edit menu would be the one that you'd want. Okay, and that's the one that you'll be modifying. Now if you want to modify any of the other ones, you would use their names instead. Now one of the things we want to do is avoid any errors or warnings so the users don't see things popping up. So we just want to first of all check that we haven't already built the menu item in the environment. Verify that it's not already there. So we'll use this function here in the first bullet called bound p. And bound p just says, has this already been defined? So we say unless it's bound to something already, go ahead and create it with the hi create menu item. So we just add that little check around it to prevent a warning. And then the second bullet, we're going to do 2 things. One, first of all, we're going to make sure the schematic edit menu exists, because remember there can be multiple triggers registered here and maybe someone registered something to remove it. So if it's not there, we don't want to try to access it because we'll get a warning. So we use the bound p function to see does this schematic edit menu exist. And we also check that if it exists, okay, by the second check we already know it exists, so we can say and not schematic edit menu arrow tr menu item, meaning the menu item's not already in the menu. So these are 2 important checks to prevent warnings. Okay. So here's an expanded example of what you're going to put in your .cds init file. First of all, you're going to define the TR user post install trigger, which will again check that the menu item does not exist. If it does not, it will create it with hi create menu item. Then in the second part of the code, it will check if the schematic edit menu is there and the menu item is not there. And assuming it is there and the menu item has not been added, it will then call hi add menu item, to add your new menu item to the menu. And again, this doesn't happen when you start the environment, but it happens later on when that trigger gets activated. So when you open a schematic window, then it will get triggered and it will add your new menu item. So the second example we'll look at here is how we add an entirely new pull-down menu to a schematic window. In the prior one we looked at just adding a menu item. Here we're going to add a whole new menu. So in order to do that, we're going to make our TR user menu trigger function. We're going to build our pull-down menu if it's not already in memory. And then what we'll return is a list of the menus to add. So in this case we're adding one, but you could build multiple ones too, and then they would all be added. And you can test your menu function before you put it into the trigger by just executing the HI insert banner menu, window ID, the TR user menu trigger function that you just defined, and then the position 0 would be the leftmost. So again, you could test it beforehand, know that it will look as you intend it to, and then you can go through the following approach that we'll look at on the next slides. So here's what we'll put in our .cds init file so that the menu gets loaded whenever we open a schematic. We'll put in the definition, which will define the new menu we're adding, or menus. And then we will register the trigger for the schematic view so that, and you'll see here it is actually the third input into the trigger. Now if you look at the notes, you'll see the code in complete detail there, where we've actually put in all the code to create the menu. We create the menu items, and then we create the pull down menu. And that's the entire data structure then that will be added whenever the schematic window is opened. Now the last example we want to look at here is reordering the layout editor pull down menus. So here we'll be using the layout view, which is actually called mask layout. So we'll have our procedure, which will do the reordering first, and then we'll register mask layout. And this is a post install trigger because we're not adding an entire menu, but we're modifying the existing menus. So it's actually the last argument as opposed to the last one, which was the prior argument. So in this example, we'll make the TR user post install trigger function do these tasks. It'll get the list of pull down menus already in the banner. So it'll look at the layout window and grab all of the menus and actually save them. So it'll save them into a variable. Then number two, it will remove them all, and then it will reinsert them one by one starting at position 0. So what then will happen is as you put the first one at position 0, it's fine. The next one comes in, it goes in, and it slides the first one down. So as you put all of them in, the last one being the first one, and the first one will have slid all the way down to the end. So you've essentially reversed them. Now here's what you put in your .cds init file. Basically, to make every layout editor window appear with the pull down menus in reverse order, what you're going to do is create this procedure called TR reverse banner menus. It'll accept the window ID as input. Then what it will do is, first of all, it will capture all of the existing menus into a variable called the banner menu list. So the HIGet banner menus window ID input will actually collect the data structures and put them into the banner menu list. So now you've captured them, you won't lose them. The next step is to delete the banner menus with HI delete banner menus, passing in the window ID. So for that second, all of the menus will disappear. You probably won't even see it though, it's so fast. And then what you'll do is reinsert them one by one back into that window. So what you're going to do is say for each menu symbol in that original banner menu list where you collected them all, grab each one and insert them in the window, insert that symbol at position 0. So again, as you do this, the first one will slide all the way down to the end and they'll essentially be reversed. So again, this is the little loop that captures them, deletes them, and reinserts them. Okay, and then the function is being called from a little wrapper function below called TR user post install trigger that takes in args automatically from the DE red user triggers, and args in this case has an attribute called window, And so we'll pass in the window ID to our reverse function. And then finally we register it so that anytime we open up a mask layout, this function will execute and reverse the menus. So again, typically you probably wouldn't reverse them, but you might reorder them. Maybe you always want, say, your new menu to be the second one, or you want to remove a menu. Again, this would be a good little template for doing that.
Here we'll look at the procedure called def user initproc to customize forms. You can see here in the syntax it takes in a context name and then a user function. And essentially what you're doing is you're providing this function to the skill evaluator so that once the context, which is all or part of the application, is loaded into memory, it will immediately call your function. So again, the order is, first of all, when a context is loaded, there's an initialization function that Cadence supplies. And then if you use this def user initproc function, the second thing it will do is call your function to customize that context. And the general purpose of this is so that you can customize the menus and forms that are defined in a given context. So here are some specifics on how to customize a form with def user initproc. It's basically allows you to set the default or initial value of a form field using a two-step process. So to use the skill language to customize a form, follow these two steps here. First of all, declare a function that customizes a form field's default value. And secondly, use the def user initproc function to register your function as a user initproc with skill. And then when the skill evaluator brings this form into memory, it loads the context, it will call your function to customize it. So a little example outlined below, and we'll look at this in more detail on the next few slides, is to have the procedure tr customize context, for example. Within that procedure, you'll have a particular form, arrow a particular field, and then you'll use def value, which is default value, and we'll set it to new value. So that way when that form appears, it will have a default value that you've set for your particular environment. And then the second part is the def user initproc. We specify the particular context that's being loaded, and again we'll discuss how to locate that. And then we give it the name of the function above that we just defined. So we're saying whenever the skill evaluator loads the schematic context into memory for the first time, then go ahead and customize it with the code above. So first thing we need to do is determine how to set the default value of a form field for input to our def user initproc function. So each field in a form built with the skill language, there's a corresponding skill expression that sets the field value. So whenever the user sets the field value in the form, the corresponding skill expression executes. Now you can observe this skill expression in the cs.log file or in the CIW if the accelerated input is turned on in the log filter form. And once you find that expression for setting the value, a similar expression sets the default value. So in the snapshot shown here, you can see we've brought up the log filter display from the CIW select options log filter, and we selected the accelerated input, meaning we'll see what's going on when people click in forms and things like that, or pull down menus. And the next thing we've done is pulled up from the schematic window the create note text form. That's under the menu called create note text. It brings up this form. And then we've typed in the word testing, because what we want to do in that file field is we want to basically seed it or provide a default value for you. So when you click on defaults, you'll get that. Now when we enter the word testing, because we've turned on our log filter to allow accelerated input to be shown, we actually see the name of the form, the name of the field, arrow value is assigned to testing. So in this case, it's actually SCH create note label form, arrow, file to read, arrow value equals testing. So now that's the syntax we're going to be using when we actually create our code. And so instead of value though, what we're going to put, and you can see it here noted here on the left here, we'll put SCH create note label form, arrow file to read, arrow def value equals testing. So that's what we'll put in our code. So the next thing we need to do is to locate the context that we need to pass into the def user initproc function. So what Cadence does is they partition applications into one or more skill contexts. And a skill context is a binary file containing compiled skill code and the data structures, including forms. Now, when you start the Virtuoso design environment, it first of all loads one or more skill contexts, the basic ones, preloaded sets of functions. Then it will load the .cds-env files. Those are environment variables for applications in different settings. And then it'll load your .cds-init customization file. It could be yours, it could be other ones in your project or in your company that are loaded also. And then it's basically sitting there with the CIW open, and then as you do other activity, that will respond to your activity by loading additional skill context. For example, when the user opens a schematic for the first time. Now what you do then is you can study the log file to see what's going on. So if you look in the log file, for example, you'll see when you first start it up, there's some initial context files loaded. Next, what it does is it waits, and then when you do something like, for example, we opened a schematic here, master inverter schematic, then it will load some additional context the first time you open up a schematic, and you can see here it's loading schematic.cxt. So that is most likely the one we're going to put in our code. Now occasionally there's other ones, and we may have to do some trial and error here to get the exact context that we need. But in this case, we're going to go ahead and use schematic. Okay. Okay, so now we know the syntax for the field that we want to set based on our experimenting with opening the form and typing a value in. And we also know the context. So those are the two things we need for def user initproc. So first of all, you see here we're going to create a procedure, tr customize create note form. And we're going to set the path to that particular field. So it's the SCH create note label form arrow file to read arrow def value equals, and we're going to point it to a subdirectory here, customization, and a file we have called notes.txt. And we're also going to we don't have to do this, but we're going to print out a message so that we can see when this actual def user initproc gets called. We're going to print out customize schematic create note form. Okay, and then we're going to define the user initproc. Okay, so we put this in our .cds-init. On the right here, you can see at the bottom, we're editing the cds-init in the skill IDE, and the same procedure is defined there. Okay, so that was automatically loaded with our cds-init when we started the code. Now we open a schematic, which you can see in the upper left there. And when we did that, if you look in this CIW, you can see that, okay, it's loading the schematic.txt. And all of a sudden that triggers our little custom function here to modify the create note form. So here we basically see that message, and then we bring up the create note text form just to see. And yes, if we do click on defaults, we do see that as our default now. And if we load it with the little yellow arrow there, it loads in our example note, and then we can place that on our schematic. So basically, if we have a particular file or setting or field value that we want to set, we can do that with this process. So that now becomes our default value for that file input for the create note text field for this session. Obviously, we could change it if we wanted to in different sessions if we modified our code in our .cds-init file. So here we'll examine how to sync a custom form with the library browser. Okay, the reason you might want to do this is because you have a form that needs input from the user on a library, a cell, and a view, and you'd like to use the same library browser utility that they're used to seeing with the library manager. So there's a couple of things you need to do. You're going to need to use the skill functions noted here. You want to create a combo field using DDHI create library combo field. And that would be for each of the fields in your form, for example, shown here that show library, cell, and view. And then initially when you, for the browse button, you'll want to call DDS sync with form as the callback there. You can see that in the last part of the code below. And then for each of the fields that you created, the callback to those fields will be DDS update sync with form. And that will synchronize the fields in your form with the library browser. So if you select something in the library browser, it'll be updated in your form. And in your form, if you select something like a new cell, for example, it will update in the library browser. So they'll be synchronized together. So here's a more complete example of syncing a custom form with the library browser. Uh, this code is essentially the code that produces the graphic on the other slide that was the synchronized form. And so we expand on some of the commands we saw there. So the procedure is called AB lib cell view combo example. The first thing we do in the left-hand box there is we create the labels that will go in the form next to the fields. So we create a lib, a cell, and a view label. Then we actually create the combo fields like we saw on the other slide for lib, cell, and view, with their callbacks being the DDS update sync with form to sync with the library browser. In the second column of code here, we create the browse button, and that actually does the DDS sync with form. And then in order to create the form, we're going to use a grid layout. It's somewhat abbreviated here, but basically we give it a list of lists, each list being the things in the form. And since it's a grid, for each label, we give a row and a column. For each basically combo field, we give a row and a column. For the Browse button, we give a row and a column, and then we also can specify which columns are stretchable, so we specify those. And then that grid layout is passed in the bottom part of the second code box there. It's passed into the HI create layout form. And we give it a title, and then we say the layout form is type grid and the size policy is horizontal expanding. So we can stretch the form to the left or the right. And finally, we need to both instantiate the form and link the fields so that the combo boxes use the other fields to inform the choices. So in this particular case, we call HI instantiate form with the layout form we created. And then we call DDHI link fields for the form lib, cell, and view fields. And then finally, once we're done with that, we call HI display form. So in summary, in this module, you learned how to customize the Virtuoso schematic editor software and the layout editor. You also learned how to customize form field default values. And finally, you learned how to sync a custom form with the library browser.